In this lecture, we are going to see how to detect strongly correlated variable. To do so, we need to import this package. So you have to import this package. I already had the package, so you don't have it. You have to import this package, and you have to load the library. So what I'm going to do, I'm just going to import this library. And then you can get the correlation matrix using the co function. So as I said previously, you can simply type question mark and type co and see what the correlation function does. Question mark co, and you see what the correlation function does here. So you can read that and see what but it uses compute the correlation coefficient. So we compute the correlation coefficient of this data set and we store in the variable CR. So doing so, we have this. So what we have in CR, you can see that CR is a set of it's a correlation matrix basically. But since you have a huge data set, it's very difficult to visualize using this technique. So you can see that the model years and X are negatively correlated, model years and observation are negatively correlated, and so on. So these are the correlation coefficient for this variable based on this. So this one, we can say that if you look at this, for instance, for this one, sex and model years are kind of strongly correlated because it's over 50%, and this is how to get the correlation coefficient. But this is very difficult to visualize which one are strongly correlated or not. You can use different technique. For instance, we are going to plot a kind of graph to visualize better. So when I run this, what we have is, so here is the CR stand for this, my correlation matrix that I compute here, and we have some parameter here. So when you look at this graph, it's very difficult to visualize, so we need a better option. So for each variable, a pair of variable, we have a correlation coefficient here, but it's still difficult to visualize. So we are going to see a different approach to visualize this. I can use the co-plot, and I pass in co, then I have my data set. So I can simply put here this CR because my correlation coefficient. So I type CR here. Let me save this. Then I run this. CR is my correlation matrix. So I can run this now. See, so you can see this technique is, I think this one is better to visualize, but still we have some. If I zoom out, yeah, this is kind of better to visualize because you can see that these are strongly correlated, and also they are strongly correlated but negative correlated on this side. So as you go from the center to here, you tend to have strongly correlated, and from the center to this -1, you have strongly correlated, but the correlation increase as you see the darkness of the color become deeper as the correlation increase. So you can tell that this variable are strongly correlated, this one and this are strongly correlated, this variable and this are strongly correlated, but still this is not very good. I'm going to remove these two observation, X and ops, these two variable, to make it easier to visualize, to make the graph nicer, because I want to have the same scale. So I'm going to remove these two to have a better visualization. So let us go back. I can remove, there's two techniques to remove. You can remove using this technique, so I subtract the first and the second column, or I can use this technique. This one is another option to use it. So you can use data equal to subset, then I type data, then I say select equal to C. So I put in -C because I want to exclude these two variables. So let's say type the name to see my name of this data set. I want to remove for X, so I put X here, and ops, this variable, so it's O B S, done. So this is I use this to subtract these two variables, but I'm going to use this one instead, this technique. Now if I type the name of this data set, you see that the name is not the same, it's no longer there. So I remove these two observations, I remove this one and this. So you see that we start by state here, which is this one. Now we can now plot the correlation again the plot, just plot again and see how it looks. So now you see that the block have the same scale. So when you zoom out, you can see that this variable for sure are strongly correlated because it's the pair of the same variable. So if you look at this one, this and these are strongly correlated based on what you have here. So they have about 0.8 correlation coefficient. So if you take this and this variable, they're also strongly correlated. It kind of, so they're around 0.5 or 0.6. But this, the negative side, this you don't have the exact number, but you have a range. You can have an idea on which part of the data set this is located. And if you look at this, for instance, like this variable and this, they are kind of negatively correlated. So these guys are negative correlated. So we had a different color. This color are all negative correlated. So that's how to get a correlation to see which variable are strongly correlated. And now we're going to move to the next section. Thank you, and see you on the next video.